So this is the robot with some electronics on it. So at the back we've got a couple of battery packs, and on top of them a Lego platform so that we can put things like these power rails. This is the Raspberry Pi with the ADC voltage measurer on top. We've got the on-off switch for the drive motor, and we've got some battery readout devices there. So if I plug in a battery for, this is the battery for the drive motor, I can see that it's got 7.8 volts, that's fine. 7.2 volts nominal, that'll be okay. I can turn on the servo power, that's got 5 volts on it. And finally the logic power, this is the Raspberry Pi, and that's got 5 volts on it. So just looking at the robot using these little voltmeters, if you like, I can tell that all the voltages are good. That's very important because low voltages can cause very strange side effects. So the power is separated into the logic battery and the servo battery because motors cause a lot of sparks and strange rubbish floating through the electronics, which messes things up. The wiring, I've got less than half of the final components on the thing, and already the wiring is getting messy. And the arm is going to go in here, so I can't afford to have wires like that going across the middle of things. So messy wiring is going to cause trouble, because on a prototype robot like this you're always fiddling with it, unplugging things and plugging things out, and when you do, you yank on the other wires, so it's a very bad thing to have anything loose or floating around. So what I'm going to do is I'm going to run them under these little Lego blocks so that they're kept tidy, and that's going to turn out to be very important. So I'm going to zoom in on some of the important bits of the robot. This is the communications heart of the system. This is a Pololu CP2104 USB to serial converter, and this is because most robotic controllers still work on the ancient RS-232 serial system. Next to it is a little motor controller, the KIK, Q-I-K, and that controls the arm motors, which will eventually be there. There's one there at the moment, which is the rotation motor. This is the Maestro. This is a fantastic device. It's got 18 configurable ports, each of which can control a servo, or can be an input, or can control an output. Basically, if you're building a robot, that's all you need really. You can do most things with just that. Because this is quite a complicated robot, I've actually got two of them. So this one here is the right Maestro, and the other one's the left Maestro. So generally speaking, what I'm trying to do is to control the left hand side of the robot from the one micro over there, and the right hand side of the robot from the right Maestro. That means you've got less wires crossing the central line of the robot, and the central line is going to have the arm on it, which is going to be swinging around, and the less wires we have crossing that area, the better. Around here we have the Raspberry Pi, and on top of it the ADC Pi, which has 8 voltage measuring inputs. You can actually measure voltages on the Maestro, but the Maestro's got about, realistically about 6 or 7 bits resolution, and that's got up to 18 bits resolution, so you can measure voltages on this as accurately as you're likely to want inside a robot. Now, a very useful piece of equipment when you're working with a robot like this is a stand. This just holds the wheels off the ground. There's just a couple of bits of chipboard screwed together, but it holds the wheels off the ground so you can check the motor control is good. Because if you don't have that, the thing can go careering off and smash itself to bits before you've had time to react. So the basic robot is now complete. What I've done is I've put in a controller for the arm rotation, which is run off this Pololu kick. I also started to put in some sensors. This is the first one. This is just an ambient light sensor. It's a light sensitive resistor measured by the ADC Pi. You can now see the arm rotation motor turning, and it works this worm drive which will, when I put the arm on, it'll rotate the arm. Up to now this hasn't really been a robot, it's more been a sort of wildly over-engineered remote control car. So what makes a robot is sensors. So the robot mantra is sense, think, act. And so we now start putting sensors on the robot, and they are various sorts. So these are simple switches. Click. And they enable the robot to stop bumping into things. And at the back we've got some infrared sensors, and this is actually a sensor, the big red button. And the idea is that if the thing is going berserk and you can get to that button, you'll be able to set up the software to stop it going berserk. So it's now a robot. So we can now drive the robot around. So I can just drive forward a little bit, backward a little bit. In remote control, but in addition I am now beginning to get some robotics in there. I can click a button that says drive forward until you hit something, and it drives forward until the front touch sensors touch, or there are infrared sensors on the back, so I can say go backwards until the rear sensors detect an obstacle. So I've got touch sensors on the front and infrared proximity sensors on the back, and that is the beginning of robotics. It's now reacting to information about the world around it brought by sensors. So we've got a robot that can drive around without bumping into things, but it now needs to be able to do something when it gets there. And this is going to be achieved by the robot arm. It's actually more of a crane really than an arm. So it lifts up and down like this, and it swivels around on this base here. The Panda is actually a loudspeaker, which is very useful to get a sort of commentary on what's going on. And in order to counterbalance the weight of whatever it's carrying and the arm, it's got another battery there, because basically you need a counterweight, and while you're on you may as well get some electricity out of it. So this is the robot arm.
Hello, I am Panda, the Pyrotechnics and Nasties Disposal Automaton. I dispose of bombs. That is all, folks.